Every complex energy system is built on great engineering. At Rosebank Mall, electrical, civil, fire and industrial engineering disciplines combined forces to build one of the most advanced energy grids in Africa. But it didn't come without its challenges. We begin with civil engineering, where structural reinforcements laid the foundations for everything to come.
This project, weighing it at 75 tons, consisting of specialized transformers, inverters, a huge battery bank, 11 kV switchgear and supplementary equipment, in the early design stages already had to take into account the civil and structural elements associated with the project. The transformers, static loads, point loads on the slabs, weight and height restrictions imposed by the existing structure had to be taken into account. The capacity of the existing structures had to be confirmed to ensure the safe placement of the electrical equipment and transformers.
Civil engineers had to carefully reinforce structural foundations to support a 6 megawatt-hour battery system weighing over 9,000 kilograms, a 5 MVA and a 2.5 MVA transformer requiring precise load-bearing calculations, high voltage switchgear demanding vibration isolation and stability. Without these calculations, the risk of floor collapse, misalignment and point loads would have been a major concern.
Once the groundwork was completed, the focus shifted into synchronizing transformers, batteries and inverters into a stable, responsive energy network.
The key of this project was to synchronize the load demand on the grid, on the existing generator banks and on the new battery storage to ensure clean, uninterrupted supply of electricity to the commercial environment. So to start out the process, we approached City Power, which is the supply authority in this area, to assist us with the grid impact study. Out of the grid impact study, they will give us the required technical information so that we can make sure our protection settings, the impact on the grid and everything is taken care of in terms of the regulations. As a professional engineer on this project, it was our responsibility to ensure that the installation is done in a safe, compliant and financially efficient way.
The electrical engineering team led by Arbitrage managed seamless grid synchronization, ensuring power transitions were done to protocol, high voltage fault protection, reducing failure risks by over 90%, load balancing automation, keeping energy distribution efficient and cost effective. The Rosebank Mall hybrid system combines municipal grid input, generator supply and battery discharge through a fully synchronized smart switchgear layout. Arbitrage's team developed the primary and secondary electrical diagrams, from high voltage switchgear to cable routing and protection. Commissioning included cable injection testing, switchgear configuration and integrating the COMAP smart controllers with programmable PLC logic, allowing real-time decision-making across all load centers.
And then there's fire engineering, because when you're working with lithium-ion batteries and high-voltage power systems, risk management becomes a design priority.
An energy system this advanced comes with significant safety considerations. One of the biggest challenges, ensuring lithium-ion fire suppression with only off-gas detection and aerosol suppression. The system uses a gas suppression system so that we have oxygen starvation of the electrical equipment so that we do not use water in the fire suppression. The system had to be designed in such a way that we could obtain council approval and certification.
Unlike traditional electrical systems, lithium-ion battery infrastructure requires specialized fire suppression measures. The solution? Gas-based fire suppression, ensuring that water is never used near battery packs. Emergency shutdown systems, instantaneously isolating affected sections in case of thermal runaway. Automated smoke and heat sensors, detecting potential failures before they escalate. A dry sprinkler system. The level of safety engineering ensures that even in the worst case scenario, power remains stable while risk is minimized.
But design doesn't stop with cables and equipment. The real question comes in on how do you turn all of this into performance, efficiency, and return on investment. That's where industrial engineering and systems modeling steps in. The focus of industrial engineering is optimization, as well as the integration of all system components. The industrial engineer considers all financial aspects, the load profiles, and finds the most optimum point to maximize arbitrage returns. But the primary focus, keeping the system stable and resilient.
Industrial engineers used data-driven simulations to predict power cost fluctuation and optimize arbitrage opportunities, to determine the best energy storage and release cycles to maximize savings, and to develop a financial return model, providing that this system would pay for itself in record time. By integrating engineering precision with financial forecasting, we ensured that this project wasn't just an energy upgrade, it was a high return investment.
Beyond the structural reinforcement, the electrical synchronization, and the advanced fire control systems, the engineering at the Rosebank Mall system makes it efficient, resilient, and safe. In our next video, we look at how all these components come together. In our final video, the commissioning, the cutover, and the official launch. Join us as we do the final reveal of the solution for smart energy systems.